Now in the previous lecture, we have learned how can we insert a node in binary tree. And we have used level order traversal for searching a node in a binary tree. Then we are deleting that node from binary tree. Now in this lecture, we are going to talk about how can we delete a node from binary tree. So here again, we have two cases. The first case is if the tree does not exist. So in this case, we cannot delete any node from this tree. And the second case is we want to delete a node which exists in our tree over here. So it's obvious that in the first case, if the tree does not exist, we just return an error message saying that the value does not exist in this tree over here. Now in the second case, we have few steps over here. And here again, I want to mention that we are going to use level order traversal for searching a node that we want to delete. So for example, in this case, from this binary tree, let's say we want to delete n3. So we know that n3 is located at the level of 2, so which is located over here. So we want to delete this node from here. Now here, the problem is, if I delete n3 in this case, so what will happen to n6 and n7? Because in this case, n6 and n7 are linked to n3 over here. So if we delete n3, these nodes also will be deleted from here. But we don't need to delete these nodes because we want to just delete n3 from here. Now to delete n3, we have 4 steps over here. Now the first step is we need to find n3. So we are going to use level order traversal to find n3. So let's say we have found it over here. Now the next step is we need to find the deepest node. So what is the deepest node? The deepest node is the one which will be visited last in case of level order traversal. So we know that in case of level order traversal, we are starting from the first level, then the second level, then the third level, then the last level. So in the last level, the rightest child will be the last node that we are going to visit. So in this case, the deepest node is n9 in this case. Then we are going to take n9's value and set it to the node's value which we want to delete. So in this case, we want to delete n3. So we are going to take n9 and update the value of n3 in this case to n9. Now after doing this, we need to delete this deepest node from the memory. So in this case, we are going to delete the deepest node because in the deepest node, we don't have any children. So it will be very easier to delete it because it's not affecting any other node. So then we are going to delete deepest node from the memory. So with this, we have successfully deleted n3 from this binary tree, and the deepest node's value is now located in the location of n3 in this case. So this is how the logic works in case of binary tree when we are deleting any given node from the binary tree. Now based on this logic, we are going to create 3 methods in practice. So the first method will be responsible for finding the deepest node, and the second method is for deleting the deepest node, and the third method will be updating the value of the node that we want to delete with the value of deepest node. Now let's head over to Java to create these methods in practice. So as I mentioned, here we are going to create 3 methods. So the first method will be to get the deepest node, and the second method will be delete the deepest node, and the third method will be delete a given node in the binary tree. So we are going to use these first 2 methods in the third method. So that's why the first method that I'm going to create, get deepest node. So here again, we are going to create these methods inside binary tree class that we created before. So here I'm going to declare our get deepest node method like this. So it's obvious that the return value of this method will be binary node. So I'm going to put it binary node and name the method get deepest node. So this method will not take any parameter because here we are going to use level order traversal and loop through all the nodes until we reach the last node. So the last node in case of level order traversal is the deepest node. So same operations here will be implemented as we did in case of level order traversal. So I'm going to create a queue which will be the binary node type, and this queue will be created based on linked list class. So if you are interested from where this queue and linked list comes from, so we have imported them over here when we are creating our class. So here linked list type also will be binary node, and with this we have successfully created our queue. So the first step that we are doing in case of level order traversal, we are adding root node to this queue over here. So I'm going to call add method of the queue with the parameter of root. Then while this queue is not empty, we are going to insert all elements to this queue, and we are going to dequeue elements from there. In this way we can identify the order of the visit. So here it's going to be like this: while queue dot is empty, basically it's not empty. Actually, before starting this loop, I need to create present node over here, which will be the type of binary node. So I'm going to name it present node, and it will be null when we are starting. So then inside this loop, I'm going to set this present node the value that comes from the remove method. So in this case, if you put like this, it's going to remove the first element from queue and set it to this present node over here. Then we are going to check that If the left child is not null, then in this case we are going to add the left child to this queue, and then we are going to do the same operation for right child. So if the right child is not null, we are going to add the right child of this present node to this queue over here. So I'm going to write if condition like this: if present node dot left is not equal to null, in this case we are going to add this left child to the queue that we created over here, because whenever we are going to dequeue the elements, in this case we want to dequeue the left children first, because in case of level order traversal we are looping from left to right. So in this case it's going to be like this: add present node dot left, and same operation will be for right child. So I'm just going to copy this if condition from here and change left to right and left to right. Now after finishing this loop over here, the node that we have in our present node will be the last node, because this is going to be the last node that we are going to visit. So in this case, this is going to be the last node that we are going to remove from queue. So if I return this value after the loop, in this case it means that we are getting deepest node. So at the end I'm going to return present node. So with this we have successfully implemented our method over here, which is responsible for getting deepest node. Now let's see how this is working in practice. So here we have created our tree and we have inserted some elements to this tree over here. Now we know that in case of insert method we are using level order traversal, so this means that the last node that we have inserted will be the deepest node in this case. Because in this case, if I run level order traversal, you will see that the last node that we are inserting will be visited last, so this means that it is the deepest node. So here after level order traversal, I'm going to call get deepest node, and I'm going to get the value of this node over here. So to see this one in the console, I'm just going to print out the value that we are getting from this method to the console. So it's going to be like this. So if I run our code, so you'll see that first it's inserting elements over here, then it's printing out level order traversal over here. Now after level order traversal, you see that we have one more N6 over here, which shows that this is the deepest node in our case. So here, instead of just printing out this one to the console, if I just put an extra new line over here by calling this print function, so you will see it obvious. So if I run our code one more time, you see that after level order traversal, it's printing out deepest node's value, which is N6. So our method works the way that we want. Now the next method over here that we are going to implement is, we are going to implement a method which is deleting the deepest node from this binary tree over here. So I'm going to declare our method like this. This method will not return anything, so that's why I'm going to put public void, and I'm going to name this method delete deepest node. Basically, we can join these two methods together and create one method instead of creating two separate methods over here. But here, I just want to make the things more clear. That's why I separated these methods into two methods. But it's possible to create a method which is responsible for deleting the deepest node and returning that node. So in this case, we don't need to create get deepest node method over here. But to make things more clear, I'm creating this method separately. So here again, when we are deleting deepest node, we are going to use level order traversal. So we know that in case of level order traversal, we need to create a queue and we need to dequeue the elements to this queue and then enqueue from this queue. So I'm going to create queue like this. So this is the same as basically that we did before. So I'm just going to copy it from here and pass it over here to make it quicker. Then we are going to create two nodes over here. The first node will be the previous node and the second node will be the current node, which will be the present node. So both of them will be the type of binary node. So I'm going to use these nodes inside loop. So I'm just going to name them previous node and present node. You can name it current node, it doesn't matter. Then while this loop is not empty, we are going to set present node to the previous node, and present node will be the value that we are dequeuing from the queue. So I'm going to put it like this: while queue is not empty, then in this case previous value will take the current present node, so it's going to be like this. Then in the present node we will get the value of first element from the queue that we are removing, so it's going to be queue.remove. Then we are going to check that if the present node's left child is null, it means that we need to set the previous node's right child to the null, because if the present node's left child is null, it means that previous node's right child was the deepest node, so we need to set it to null. And if the present node's right child is null, it means that present node's left child is the deepest node, so we need to set the present node's left child to null. So it's going to be like if present node dot left is equal to null, So we have reached to the case that in which the present node's left child is null. So this means that previous node's right child was the deepest node. So this means that we have to delete this node. So I'm going to set previous node's right child to null. Previous node right is equal to null. Then after doing so, we have to stop our loop. So that's why I'm going to return. Then we are going to write second if condition. If the present node's right child is null, it means that present node's left child was the deepest node, because after left child we are coming to the right child and we see that in the right child we don't have any value, so this means that deepest node was the left child. So it's going to be like this: else if present node dot right equals null. In this case we are going to set present dot left to null. Then after doing so we are going to return one more time. Then in this case, if we have not reached these cases over here, we have to add left and right childs to this queue over here, because every time we need to dequeue the elements from here. So that's why if we have elements in the left and right child, we have to add them to this queue over here. So first we are adding, as always, left child, because in case of level order traversal, we are looping from left to right. Then we will add right child. Now after doing so, we have successfully implemented our method over here. Now let's see how this is working in practice. So here again, we are going to call this delete deepest method for this tree that we created over here. So here in our tree, we have 6 elements. So if I delete one element from here, the deepest element we know that is n6. So it's going to delete n6 from here. So after calling level order traversal, I'm going to call delete deepest node. Then after calling this method, we are going to call level order traversal to see the differences between the previous one and the one that is after the deletion of deepest node. So here, before calling level order traversal, I'm just going to call println function one more time to have space between these levels orders. So if I run our code, you will see that initially, when we are calling this level order traversal, our binary tree was like this, so in which we have 6 elements. Then after deletion, when we are calling level order traversal, in this case, it was this like this. So in this case, you can see that n6 is deleted from this binary tree over here. Now we have successfully implemented our method in this case also. Now after implementation of the delete deepest node, we are going to implement our main method, which is responsible for deleting a given node from the binary tree. So here under the delete deepest node, I'm going to declare our method like this. So I'm going to name it delete given node. Now here I'm going to declare our method like this. So in this case our method will not return anything, so I'm going to put void delete node. Then as a parameter, it's going to take value of string. So in this case, this parameter will identify which node we want to delete from the binary tree. Now then, the first thing that we are going to do, we are going to use level order traversal to find the value that we want to delete from this binary tree. So we know that in case of level order traversal, we have to create a queue and add the root node to this queue over here. So I'm just going to copy this code from the delete deepest node method. So this part is same. So then we are going to check that while the queue is not empty, we are going to loop through the elements one by one, and we are going to enqueue and dequeue the elements from the queue over here. So it's going to be like this: while queue is not empty, in this case we are going to call the dequeue method. So in this case we are calling the remove method, and we are going to set the value that comes from the dequeue method to the present node. So in this case I'm going to create the type of binary node which will be called present node. So it's going to set to queue.remove. Then we are going to check that if the present node's value is equal to the value that we are looking for or not. So I'm going to write if condition like this: if present node.value is equal to the value that we want to delete or not. So if it is equal to this, so in this case we are going to change the value of this present node to the value that we are getting from the deepest node, and then we are going to delete the deepest node and return message saying that it's successfully deleted. So in this case it's going to be like this: present node.value is equal to get deepest node. We are going to call the get deepest node method. So we know that when we are calling get deepest node method, it's returning the type of binary node. So if I access the value of this deepest node's return value, in this case we are going to access the value of the deepest node. So I'm just going to put it dot value. So with this line of code, we are setting the value that we are getting from the deepest node to the present node's value. So this means that the present nodes will not be available in our tree anymore. So with this, we have successfully removed the node with this value over here. Now in our present node, we have the deepest nodes value. So this means that after updating this present nodes value to the value that we are getting from the deepest node, in this case, we have duplicate value in our binary tree. So this means that we have to delete the deepest node in our binary tree. So I'm going to call after this one, delete deepest node method. Then after calling this, I'm going to return message to the console saying that the node is deleted. So it's going to be like this: system out print the node is deleted. Then I'm going to put return. After doing so, we need to return because we don't need to continue anymore. Now in the else condition, if the present node's value is not equal to the value that we are looking for, in this case, we have to add right and left children to this queue over here. So in this case, I'm going to put if conditions like this: if present node.left is not equal to null, in this case we are going to add the left child to this queue, so as we did over here. Same operation will be done for the right child also. So I'm just going to copy it from here and post it over here, and it's going to be right and right. At the end of the loop, if we cannot find the value that we are looking for, in this case it means that we cannot delete this node from this queue over here, because this node is not exist in our binary tree. So I'm going to print out to the console saying that the node does not exist in this binary tree. Now with this, we have successfully implemented our delete method over here. Now let's see how this is working in practice. So here, one more time, we are going to delete a node from this binary tree that we created over here. So instead of calling delete deepest node, I'm just going to call delete node method. So let's say in this case, we want to delete the value of n3 over here. Now we know that if you delete n3 from here, n3 will be deleted and n6 has to move to the place of n3, because in this case n6 is the deepest node in our binary tree. Now if I run our code, now here again, let me just make our code more readable. After level order traversal, let me just call one more time println function. So let's run our code. You see that after creation of our binary tree over here and after inserting elements to the binary tree, we called level order traversal. So in this case, we have 6 elements in our tree. So then we called our delete method. So we are deleting n3. So it returned message saying that the node is deleted. So we have everything fine over here. Now then after deleting the node, we are calling level order traversal. Now in this case, you see that initially our third element was n3. Now our third element is n6. But initially n6 was the deepest node, so that's why n3 gets deleted and n6 moved to the place of n3 over here. Now from here we can see that we have successfully implemented delete method in binary tree for deleting any given node in the binary tree. Now with this, we have completed the implementation of our method. So let's see what's the time and space complexity for this method over here. So here again, we are going to start from the first line of this method. So in the first line, we are creating queue and adding root node to this queue over here. So these 2 lines of code will take a one-time complexity. Then in the loop, we are looping through all elements of the queue. So in the worst case, it means that if we cannot find the element that we want to delete, it means that it has to traverse through all nodes of the binary tree. So this means that if we have n element in our binary tree, it's going to take n time complexity. Now then inside this loop, we are creating a present node and assigning value that we are getting from the queueRemove method. So this will take a one-time complexity. Then here inside this if condition, we are checking that if present node's value is equal to value, we are doing some operations over here. Now in this case, inside this if condition, we are calling get deepest node and we are deleting deepest node from the method. Now here, get deepest node method uses level order traversal. So we know that in case of level order traversal, it takes n time complexity. So this line of code will take n time complexity. So similarly here again, when we are deleting deepest node, we are using level order traversal. So this one also will take n time complexity. Now the next line of code will be O1, because here we are just printing out message to the console. Then in the else condition, we are checking that if the present node's left child is not null, we are adding that one to the queue. And this operation over here is not time consuming, so this will take a one-time complexity. So now in the next line of code, we have same operation for the right child, so this one also will take a one-time complexity. Now at the end, we are returning message to the console, and this one also will take a one-time complexity. Now if we combine all these complexities over here, it will be n. You might be interested that this part of code over here takes n time complexity, and it is located inside this loop over here. So the result should be the n square time complexity. But here you need to take into account that we are not calling these methods for each of elements of the queue. So here we have if conditions. So this means that these methods will be called only one time. So that's why if you combine these methods together, it will take O(n) time. Now the space complexity is also O(n) because in this case, we are creating a queue and inserting all elements of the binary tree to this queue. So that's why we have to allocate a space in the memory. So this will take O(n) space complexity. Now with this, we have come to the end of this lecture. So in this lecture, we have implemented the logic how can we delete a node from binary tree. So here for deletion of a node, we have 4 steps. So we need to find the node, then we need to find the deepest node, and we are getting the deepest node's value and assigning to the node that we want to delete. And at the end, we are deleting the deepest node from the memory. Now, hopefully, everything is clear about deletion of a node from a binary tree. So see you in the next lecture.